Hello all. So today's lab is about AWS serverless, and in this lab we don't have any theory, so it's all hands-on. So in this lab you'll learn about multiple services. So before going to services, let's do one exercise. So there is a prompt. So you are a cloud developer, cloud engineer working at a company. You have received a request from some manager for your vote polling application. The requirements are create a temporary feature, emphasis on temporary, to store the polls from developers. So if you know, like Stack Overflow does polls every year, like which is your favorite language, and then at the end they show the most popular language among the developers. So something like that, you need to create a temporary feature to store the polls coming from developers, so like in APIs, and then you need to store the polls in DynamoDB, and your solution should be scalable. It should increase and decrease as per the demand. So for now you need these things, and then you need to create a solution in such a way that you can add the authorization later if you need it, and also have room for adding more features as per the requirements coming, with minimal effort and highest performance. So far from all the service you know and learned, so please suggest like which services which you will be using for this. So there is one DynamoDB here, so database is DynamoDB, but you have some applications, so you'll need some servers or XYZ, something like that, and it should be scalable and also have room for new features with minimal effort. So Beanstalk for server deployment, yes, you can. Oh, sorry. Okay, yeah. Okay, so one argument is Beanstalk and one is Lambda. So which one is scalable? So are both scalable? Okay, and does the demand automatically increase or decrease in both of them? Okay, and it says like you have to have like temporary features. So which is better for temporary feature? Beanstalk or Lambda? Okay, and then minimal efforts. So Lambda. So Lambda will be a good choice for like solving the APIs, but then it asks for the solution should be developed in such a way that you can add authorization to the Lambda. So can you add authorization to Lambda? Yeah, so if you use gateway, then it can provide authorization as well as add more features as per the requirements. So you can add multiple APIs in the API gateway and connect it to some EC2 server or Lambda or Beanstalk. So it will take minimal efforts, provide the highest performance. So as a cloud engineer, the architecture which you will suggest would be like Lambda, API gateway, DynamoDB. Yeah. Yeah, so like in the API gateway, when you create an API, you create a resource and method, right? Like resource and then name of the method, post, get, anything. Then when you create a method, you need to integrate it somewhere. So it gives you option like HTTP, Lambda, XYZ service. So if you click on HTTP, then you can attach any HTTP like forwarding API to that API gateway. For example, your server is Node.js and it is running on 3000 port. So you will give the EC2 IP address 3000 in that HTTP of API gateway, and then it will connect to EC2. But if you have another API connected to Lambda, then one API is for Lambda, one is for EC2. So it works. Yeah, so give the IP of load balancer, like DNS name of load balancer in your HTTP. Yeah. So no, so you create one API gateway, and in that API gateway you create multiple resources or methods. Just like here, there is this AWS US East 1 DNS. So if you write Lambda, then it will go to Lambda. But if you write EC2 here, then it will go to EC2 dashboard. So this is resource name. And when you click enter on this URL, it sends a GET request. But if you need, like, if you're storing something, then you use post request, right? So that they are called methods, and this is called resource. Yeah. Yeah, so first of all, like, why do we need a API gateway? Sorry? So let's say you have three services, three different applications, and user like access it directly. So this is user. So when user access it directly, they will call an API and access this and this and this XYZ. So now you need to add a authorization for all the services. So you will have to add the logic of authorization into all the services. But then, okay, you implemented that, right? So you build the authorization part. Now, if you have worked on OpenAI APIs, in the free tier, they provide like 10 APIs per day, something like that. Calls. So how do they track it? It is called rate limiting. So when API comes to your server, if you have rate limiting set up, then you can set a number like 50 APIs per second. So for this, I need 50 APIs at most per second. So if it exceeds 50, then it should block the incoming APIs. So this is called rate limiting. So there could be XYZ features which are needed for all the APIs, like all the services. So that's why you create a unified API system, which is connected to all your services, and then you implement authorization here, rate limiting here. That way, your logic is only present in your service, and everything else is handled by API gateway. So that's why you use a centralized API gateway. So is it clear now? Okay, so let's move to the hands-on. So AWS Lambda. So you might already know it. So it is a serverless service of AWS, and when we deploy our application on a server, we need to have a compute machine, have a server, have it running every time, like all the time, to access your resources. But if you use AWS Lambda, it is serverless. So like as name goes, you don't need to create a server, but there will be a server somewhere. It will be managed by AWS. So that's why it is called function as a service. So you create a function on AWS Lambda, and initially it is like not running. So when a request comes to the function, AWS will set the environment up, set the server up, and does like the computation part which you have wrote in your function. And once your function is executed, it will stop the function after some time. So that's the gist of AWS Lambda. AWS Lambda is scalable. So if you have more requests coming up, it will scale itself, and it will scale down when there is no request. So it will kill the function. And AWS also gives you option of like selecting a CPU for your Lambda function. So for example, if you need a high power CPU, then you can select the CPU from AWS Lambda. And by default, the Lambda execution time is 15 or 30 seconds. So if your computation on your Lambda function requires more time, then you'll need to change the execution time of Lambda function. Otherwise, it will like stop itself. And the maximum a Lambda function can run is for 15 minutes. So you don't run a data cleaning task on Lambda. It has its own purpose. If you need some data cleaning task, then you use server, etc., which takes a longer time. So the tasks which needs 15 minutes or less time are used like done by AWS Lambda. So there are some use case for it, and it is used for that. So any doubt? Okay, so let's go to the dashboard. So these are 5 default functions which is created by AWS Academy. So we'll create a new function. So when you go to create, you can create a function from scratch. You can create a function from Blueprint, which is provided by AWS, or you can use a container image. So we'll do it from scratch, and I'll name as lab8 lambda function. I'll use Python. Architecture is, there are two architecture, ARM64 and x86. So traditionally x86 is used in PC, and ARM64 is like a CPU which is used mainly in phones. But if you know, like Apple has released their own M1 chip, M2 chip, and all, so they are based on ARM64. And like it is kind of a revolution for PCs. So in the coming years, Windows will be like, Intel will be also creating ARM64 machines, and you will also get like powerful laptops in PC world, just like Apple. So it is like mainly used in the, it used to mainly used in the phone, but it can be also used in the machine. So if you use ARM64, it will be cheaper than x86. So it is something to know. But not all the libraries are covered, like supported by x86, like ARM64, because it is still developing. So for some libraries, you might face any error. So for learning purpose, use x86, but thing to remember is like it is cheaper than this one. So a fun fact about it. Okay, so next step is, so when you click on the runtime, it selects the programming language, then architecture of your function. Then next is execution role. So for this AWS Academy Lab, you can't create a role. So you will have to go to use existing role and then go to lab role. So there is a role created for you, which you already used in EC2 and all. So always go to use existing role and then select a lab role. Otherwise, it will fail to create a Lambda function for you. And then in advanced, there is code signing. So let's say multiple developers are developing a Lambda function. So if you have code signing, then you will know like which one has wrote which thing, and you can sign the code. We'll come to function URL later. Tags are like if you want to attach a tag to Lambda function and enable VPC. So when you create a Lambda function, it runs on the AWS cloud, not inside your VPC. So if you want to run a Lambda function inside your VPC only, then you'll need to do this thing. So that way, your Lambda function will be running inside your VPC, not outside. And like when it runs in your VPC, like the server which will be created by AWS will be inside your VPC. That's the meaning of it. So I'll create a function. So when you create a function, it opens a window like this. So you can write your code here, or you can write your code locally, zip the code, and then upload here. But then if you do that, then you can edit it in the console. So you can use either way, but not both. Okay, so before going to the functions, we'll first go to this part. So in Lambda function, there are triggers and destination. So what are triggers? So let's say triggers are like events. So you can set a trigger, and whatever trigger you have set, it will call the Lambda function after that event is triggered. So for example, if you go to trigger, add trigger, there are this many triggers there. So if I write S3 here and select the service, then name of select any bucket, then which type of trigger you want. So for example, I'll select a port trigger, which means that if I upload anything in my bucket, then it will like trigger this event. If I do the post, then again, so for post, it is like if I store any new thing in my bucket, it will call this. If I push a new thing or update something, it is called post. So if I add a put trigger here, then this is optional. And if I do add, then whenever anything in my bucket like is changed, something new is uploaded or existing thing is modified, it will call this Lambda function. And you can use the metadata from this event variable. So in the event variable, you will know like which file is added, or like which file is added in which folder, etc. So all the metadata of that file will be given in this event variable. So whenever you connect a Lambda function with API gateway, you will see API gateway here because it is an trigger. So any doubt in trigger? Yeah.
So let's say in this scenario, using my Lambda function, I'm putting to the same S3 bucket. So will that create a recursive?
So 2 S3. Okay. So yeah. So if you put 2 buckets here, and one bucket is storing something in second bucket, like if you create a loop, then it will like create a loop in Lambda, and then the Lambda won't stop, but you will like face so many high chat because it is computing a lot of things and it will never stop. So like never create a recursive loop in Lambda. Next is destination. So just like a trigger, when something is triggered, it calls the Lambda function. So destination is like when Lambda function is finished, it will call something in the destination. So after Lambda function execution is finished, you go to like it will go to destination if you have added something in destination. So let's go to destination. So in destination, there are 2 things: conditions, on fail, on success. So what if your Lambda function fails? What do you do? So for our project use case, we don't generally use destination thing, but let's say there is some API there which stores data in DynamoDB, but it fails to store the data in DynamoDB, but you still want to preserve the data. So what you do is create a destination, add a condition on fail, set a destination type to SQS, and then select the SQS things. So what SQS is like a pipeline which have jobs. You can put jobs in that pipeline, and it will be processed by something which we have set. So basically that is, so it is a queuing mechanism thing. It is out of scope for this lab, that's why I'm not covering it much, but it is like that. So you can pass something from Lambda to SQS, SNS, or even a different Lambda function. So if a Lambda function fails, it calls a different Lambda function. So this is what our destination does. So any question in destination?
So on failure means status code find or something.
On failure is like if you are returning something on failure like 500 or any error raising any exception if a Lambda function stops on runtime, because you can have errors in your code, right? So it will be on fail like that. So I'll just remove this one first. Okay, so this was trigger and destination. So next thing is layers. So what are Lambda layers? So let's say this is a Python code and I want to call a API from this Lambda function. So if I do request.get and then call some API and response equal to this, so this won't work here. Why? Yeah, so this won't work because this library request is not installed in the Lambda. But then how do you install it? There is no console here. So you use layer for it. Same way in Node, there is package.json file which install the list of packages like dependencies. So it creates a node model folder, right? So same way in Python, it like creates a virtual environment folder or the folder with libraries XYZ. So for this case, what you will have to do is, if I go to layers, create a layer, then you give a layer name. Let's say I'll give lab8. Then it asks for a zip file. So what you should do is create a folder. You can name it anything. Go to that folder. So this is for Python. So go to that folder, then do pip 3 install request -t and dot. So if you write -t and dot, it will be installed. So like this needs a path. So when I write -t and dot, then it installs request package in my current folder. So if I do this, then it has created this request package in this Python folder. And the next step you have to do is zip it and then upload it here. So whatever things which is needed for your code to run, you need to install it in a folder, then zip the folder and then upload it here. So it will create a layer for you. And then once the layer is created, you go to your Lambda function, add a layer, and then it will be a custom layer, and then you can select your layer from here once the layer is created. So this is how you create a Lambda layer. So you know the use case, right? To run a program in Node or Python, you'll need some packages. So to run those packages, this layer is used. So for most cases, you'll be using a layer here because not everything is installed by default in Lambda. So like if you just want to call some AWS service from Lambda, then you can import Boto3, so it is installed by default. So you don't need to install Boto3, but everything else you'll need to install. So any question? Yeah.
Is there any specific format on how to upload, for example?
Zip folder.
No, node modules is a separate folder that will be zip the file with the JS file.
No. So like you don't provide your code file in layers. So when you create a layer, which means that you are running, like you are building your function in this console. But if you zip everything with your code, then you need to upload it from here, not from the layer, because you are packaging your libraries with your source code. So like you have everything in that zip file, so you just directly upload it from this Lambda. Got it? So there's a difference here.
But in Python, for example, it goes to the separate folder that Python standard. For Node, it's different. It comes in the folder where the code is.
So when you create a Lambda function, you have to select Python, Node, etc. Right? Language. So it knows like.
In the layers.
Yeah. So like again, two things. If you are using layers, then you are coding here. But if you are not using layers, then you are coding on your local machine, zipping everything in a single folder, and then uploading here. So there are two ways to develop Lambda function.
So when we use an import in a Lambda function, does it look for the layer or does it?
No, it doesn't look for layers if you have not provided here. But your dependencies will be there in the zip file, then it will take it, just like that. You don't need to create a layer for it. So two ways you can use Lambda. Okay, so let's create a sample Lambda function. Let me get this thing. So I want to return an HTML content, and I'll write hello from Lambda. So when you do any changes to a Lambda function, you'll have to deploy it always. So yeah. So whenever anything is changed in Lambda function, you'll have to deploy it. So let's say you have deployed this function, then how to test it? So to test it, you click on this test, then give it a name. I'll write demo test1. Then this is the input which you want to provide to Lambda function. So I'll keep it as it is because I'm not using it, and the test is created. So if I do test, then it will run the Lambda function, and this is what is written from my Lambda function. So this is how you test a Lambda function from this console. So now how to test this Lambda function from my application and API. So like Lambda function has a service called, like a feature called function URL. So if you go to configuration and then function URL, then you can create a function URL in Lambda. There are two options, authentication options. So I'll select none, but if you want to create a URL which has an authentication, then you can use AWS IAM, and then I'll enable the CORS as well. So if I save it, then it creates a URL for me, and using that URL, I can access the Lambda function. So right now I'm returning the HTML content, but never host your website on Lambda function because generally websites are static. So this is how you access a Lambda function from outside. So any question in this? Okay, so now one scenario. Just like you have your group project in serverless and you're using Lambda function, and multiple users are using same Lambda function. So one user made a recent change on their Lambda function, but the second user was not aware about it, and they overrode the Lambda function. Now first user's Lambda function is gone, and your production Lambda function is now failing. So how would you fix this issue? Yeah, so what you should do is create a Git repo and then commit the changes and then push it to Lambda, but you're not doing that, let's say. So what you should do is, so I'll write hello from Lambda v1, deploy it. So I've created this Lambda function. So when you feel like this Lambda function is functional and working, what you should do is go to action and publish a new version. So when you do that, then it will ask for version description. So I'll say like my production Lambda. I'll give this description and publish it. So now Lambda has created a version for your function and you can't edit it. So this function is immutable now. So it is just like a deployment on production. If something is working, then you make a version of it and then deploy it. And then when you want to upload it or like update your existing production server, then you update the code, create a new version, and then use it. So this is a Lambda function here, and you see here there is one colon. So when you run this, not this one. So let's go back to the version. Okay, so we'll come to the next thing. So this is a Lambda version. So if I go to the code here, let's say I am updating the code and writing v2 here and then deploying it. Now I'm creating another version called my v2 version. So there are two versions on my Lambda function. And the next thing in Lambda is alias. So if we go to alias and then if I create an alias and give it a name of production. So when you create an alias, you can select which version this alias is pointing. So let's say my production alias is pointing at version 2 and I save it. And I'm creating one more alias for name of development. And it is pointing to latest. So development alias is always pointing to latest and production alias is pointing to version 2. Now, when you create an alias, you can create a separate function URL for each alias. So I'm inside this development alias. So I'll go to function URL, create a function URL. I've created an alias for this and I'll also create one alias for production. So this is my production alias. So if I open this, it is giving me hello from Lambda v2. And if I go to my Lambda function, I'm writing v3 here, deploying it, going to alias, going to deployment, opening this. It is opening my v3 version and this link is opening my v2 version. So I have a different function URL for my production alias and different for my development alias. So if you create alias in Lambda function, then you can segregate your production and development Lambda function. So let's say some new change is required in your Lambda function. So you write I made a new change, you deploy it. Now you want to deploy this version to production because your development is done. So what you do is create a new version, give a description for it, publish. Now go to alias, go to production. I think it is done using here. So go to production, click on edit, version 2 to version 3. Now, remember in the last lab, I explained different types of updates, rolling update, all at once and all. So you can do weighted updates here, which means like if I select a version, old version here, a new version here, then if I give 50% weight to this, then this Lambda function will gradually increase the weight from this to this if it is like working successfully. So this is kind of a deployment strategy plotted by Lambda function. And it is like a, let's say, blue-green because it is weighted and then this weight will be lesser and lesser and this will be increasing and increasing as per the time goes and then it will be deployed eventually 100%. So this is a kind of deployment in like Lambda. So if I save it, then this was my production. So this production version is deployed on Lambda. So you can manage your environments of your Lambda function like this. So any question? Yeah.
So we created this development alias. It has its own function URL. At the same time, this Lambda has its own function URL. Both of them return the same data.
Yeah. So this Lambda, this development alias is pointing to latest version of Lambda function, and the Lambda function URL always points to the latest one. So whatever URL you use, development or function URL of Lambda function, it is pointing to same version of Lambda. But this production is pointing to version 3 of Lambda function, which we have created. And that is why it is pointing to that part of the code. So any question?
What is the weights from different versions? Let's say one of the version is down. Maybe we will
Yeah, so it will handle it and then, yeah. I don't think that is possible, sorry. So what Lambda will do is like it will gradually redirect the load incoming to any version. For let's say here we selected version 3 and 50% load, version 2 50% load. So let's say 1,000 requests are coming. So it will send 500 requests to version 3, 500 to version 2. Then after a few time, it will send 75% requests to version 3, version 2, and then like that. So it will like not roll back, but it will divide the traffic like this.
So if any of the version is down, let's say the updated new version is down.
Yeah.
Then the one
So-
version is good to, or is this 500 then will be good?
So in this case, what the DevOps team do is like check the logs of Lambda function and see if version 3 is failing or not. If yes, then they can like delete this, like point to v2 again. But if it is not, then it is like kind of helpful for you to have weighted like load because you can always check it on the runtime. So that's the use case here, not the complete rollback. Okay, so next thing is monitoring. So when you run a Lambda function, you can have your logs, like have print statement here, and it will be logged somewhere. So where it is logged. So it is logged in CloudWatch. So if you go to this monitor tab and click on this, view CloudWatch logs. So CloudWatch is a service which stores the logs of like anything like EC2 logs, any log of any service. So it creates for every Lambda function, it creates a log group, and in that log, it will create this file and store your logs here. So whenever you redeploy your Lambda function, this CloudWatch will create a new file for your Lambda function. So it won't append it in the old one. So always refresh it when you deploy a new version, and then see the logs. Use the latest one to debug. So have some print statement in your Lambda function so that you can know like if something is working right or not. And that's the only way to debug the Lambda function on the runtime. So we covered trigger, destination, function URL, versions, alias. Then permission is like you can see what are the permissions which is there like allocate to this Lambda function. So since it is AWS Academy account, so you can't really edit the permission here, but you can like see here. Next is environment variables. So when you run your code, you always have a configuration file which have your configurations. So just like that, you can have environment variables in your Lambda function. So let's say I have a environment variable for port number, which can change at any time. So I'll create a Lambda function like environment variable for that and save it. So if I go to code, if I do import OS and then port equal to OS dot, if I do like this, then it will fetch the port from environment variable. Just and same thing will be in Node. So why do you use environment variable? Any reason to use environment variables?
For every different environment configurations could be different
Uh,
for consistency.
No. So you use environment variables because you don't need to redeploy your Lambda function again and again. You can just update this environment variables when you need it, and you don't need to redeploy it again. So the things which are changing a lot or are constant should be put in environment variables, so that you don't have to redeploy your code. Okay. Okay. And one more important thing about Lambda function is like you have to follow this. Is so let's say you are creating a connection to database from your server. So what generally you do is write a function get connection and then return db.connection like this, something like this. So you usually create a function and then call this function whenever you want to call some query of database. So you call this function, it will return a connection, then you can call a SQL query after that, right? So generally this is what you do. But in Lambda, whenever you are making a connection to anywhere like DynamoDB, Boto3, something RDS, you always put it at this part, like outside the Lambda handler or outside any function. So like here DynamoDB equal to Boto3 dot resource DynamoDB like this. So always put this here. Why? Because whatever you initialize outside the Lambda function is shared by all the Lambda functions. So let's say this takes 5 seconds of time to create a connection here. So it will only create like once, and other Lambda function will be using this connection only. But let's say you are creating a function and then writing this here. So whenever you are calling that function, it will take 5 seconds every time. So for best practices, use it like this. Don't like put it in a folder. Okay, and I think everything is covered in Lambda. And one more thing is concurrency. It's outside the scope, but let's say, so for Amazon has 2000 concurrency limit for a Lambda function, which means like 2000 Lambda function can run at a instance point of time. So it is shared by all the Lambda function present in your account. Let's say this is Lambda 1, Lambda 2, and so there are 3 Lambda functions, and this concurrency limit 2000 is shared by all the Lambda functions. So if this Lambda function is calling like 1500 times and they are calling like 250 times, it will be 2000 here. So you need to set a concurrency limit in your Lambda function so that it doesn't exceed to some number. For example, this needs 500 connect like Lambda function, this needs 500, and this uses 1200. So then one of those will fail, or this one could fail because there are 2200 requests coming in. So what you do is set a soft limit of like 1000 concurrency limit at any time. So if this number exceeds, then it won't create a new Lambda function for this. So this is called concurrency in Lambda. So you can set it like this. So what usually you should do is in your read APIs, read Lambda function, if it is like reading for CRUD operations, so give it more, and for write, give the concurrency limit to 250, let's say, because you have less write operation than read operation. So this is how you do it. So any question about Lambda? Yeah. So like when you upload a zip file, this code will be the same as it is. Like the code will be same, like the format is different. No. but you can host your Lambda function in your VPC. So any question? Okay, so this was all Lambda function. Now we'll go to next service. Yeah.
We can access the function URL directly. Then why do we have to create a API gateway on top of the function name?
Yeah, good question. So why do we use API gateway on top of Lambda function? So like remember I told you rate limiting, authentication, and XYZ extra feature are provided by API gateway. That is why API gateway is used. So again, you can use function URL to directly use the Lambda function, but API gateway provides more features to your Lambda function or APIs. That's why you use API gateway.
But we can secure the function URL.
Yeah, it is HTTPS, I think. Yeah, your function URL is like already HTTPS, so it is secure. Okay, so next service is API gateway. So I already covered the theory of API gateway, why we need it. So I'll just like go to the service directly. So in your API gateway, there are 4 types of API. First is HTTP API, which is a cost-effective API, but it doesn't have all the features, and it is easier to use like this. To like it is quickly, you can create quickly APIs for your application using HTTP API. REST API is like a superset to this. It has more features, and that's why you will have more control over your APIs. So the difference between this is like it has same things here, but it is easier to create your APIs in HTTP API, and it has less features. This is costlier, but it has more features. This is like running your API in your VPC. So just like Lambda in VPC, it is API in VPC, so it is called private. And WebSocket API is like, have you heard about WebSockets? So just like in HTTP API, there are WebSockets. So if you want to create a WebSocket API, then you can use REST to build your APIs. So we'll create REST API because this is easier. Okay, so when you create a REST API, it will ask for import API. If you have any like configuration API already created, you can import it. You can clone the existing API, or you can use this example API. So we'll create a new API. I'll write lab 8 API. API endpoint types. So there are 3 endpoint types. First is regional. Second is edge optimized. Third is private. Private, just like name goes, it is a private like API. And then regional is like this API will be running on your region level, which is US East 1. US East, not 1. US East region. It will, and then what is edge optimized? Can anyone tell? You learned about edge in AWS infrastructure. AZ, region, and edge. There are 3 things in AWS. So edge are used for CDN, content delivery networks, like for caching. So have you heard about CloudFront? Okay, so edge networks are basically used for like fast. So it is used for caching at the end. So if you use edge optimized, then your API will be deployed on CloudFront, not at the regional level. So I'll create the API. Anyone in 5902? You should know about this. Okay, so when you create the API, the console is like this. So let's create few Lambda function for this API. So I've created Lambda function here. So just like the example which I gave in the prompt, I've created a get polls Lambda function. So I'll just create that. Python 3 lab role, and then create. I'll paste this here. So it is using a DynamoDB, so I'll just create a database first. So poll ID, and I'll create a DynamoDB here. So I'll deploy this Lambda function. Then I'll create one more Lambda function. And then deploy it. So I created 2 Lambda function. Now I have not created a function URL for any Lambda function because I'm going to create a API gateway and then call the Lambda function. So when you go to API gateway, you can create a resource or create a method here. So currently there is this slash, it is like a base path. So I'll create one resource called get polls and then create it. So I created a resource with the name of get poll. Now I'll create a API. So when you create an API, it asks for these things. So if it is calling different AWS service, Lambda functions, HTTP, a mock API, or a VPC link. So we are connecting to Lambda function. Type of API is get. Now here I'm like select the Lambda function. So I'll select get polls. And when you connect like a Lambda function to API gateway, always keep this on Lambda proxy integration because it like converts the incoming data, which is like good, required by Lambda. So it does that. So keep this on. and then create method. So I have created one API of get type, and the resource path is get poll. Now I'll create one more API. So I'll go to this base path, create resource. I'll write polls, just polls, or store polls. Create it. Then in this store polls, I'll create a method. So to store anything, you create a post method. Then again Lambda integration, and I'll select the store poll and then integrate it. So created two APIs. Now once the API creation is done, you need to deploy it. So how to deploy? So if you go to deploy API, then you'll need to create a stage for your API. So currently there are no states. I'll write production. You can have multiple stages. So just like in Lambda function we have alias, in API gateway you have stages. And this is the invoke URL for the API. So if I go to this get polls, let's double check it, get polls, and then run it. Right now there are no polls, so it will give this error. So first I'll just save some data in my DynamoDB. So I'll open Postman, create a post API, store polls, poll ID. I'll write 1 and then language Python. Internal server error, so how to debug it? Anyone? How to debug Lambda function? Okay, so there are no errors right now. So let's just first try to run the Lambda function here. So this one is store polls. I'll run the get first. Let me first just add some data. Okay, it is stored, but it gave me error. So a data is stored here. So if I do Java and then name the poll as 2 and then send it, it is giving me this. So we'll see like why. So like the error is in returning the response. So right now I'm returning this response, but it is not returning from the API gateway. So the error could be in API gateway. Sorry? No, because I'm sending it via Postman, so the course error won't be an issue for Postman. Same for get. Let me go to get API. So the one thing about Lambda is you can also test it from here. So if you go to test and then you can give the parameters from here, and if you go to test, then it always returns this internal server error. And let's see the error. So let me try to return. Go to API again and test. So it is giving me internal server error due to configure error malinform Lambda proxy. Let's just keep this closed and see if it works. Okay, so the integration type is causing the error. I think like for this we need to set few things. I'll check it from my end and then let you know after the lab. So it should work now. I will check if I've deployed it. So whenever you make any changes, you'll need to deploy the API gateway again and then run it. Same error, but now here I'll select Scala and then T and then run. So it should work, not sure why. Here it is giving me success. now it is working. It's like this thing which you will face in industry as well is like whenever you are giving a demo, it will fail, but it will work fine in your local. So very common. But then like if this error comes up, then you will get to learn like how to debug them, and then that way it will be good for you. So now my get poll is working. I'm running out of languages. Rest. Okay, so now something came up. So now everything is working. So if I uncomment this, comment this, and deploy it, and then do the get, I'll get the databases now. So in the integration part, you should select when there is no template defined recommended option. This was selected, which was causing the error. And there's a feature in like, so like when I said like if you use REST API, then you'll have more control over your APIs, which means like whatever data you are sending from Lambda to API gateway, you can even filter that data here in the API gateway, and then send the filtered data to users, not everything. So these are the functionality which is provided in the REST API, not HTTP API. So use this option when you create the Lambda. I think we'll run out of time, so I'll go to next, which is step functions. So the next service, so whatever we are like working on right now, all the services are serverless service. So step function is also a serverless service, API gateway is also a serverless service, and Lambda also. So what is step function? So step functions, so if you have in your undergrad you learned in TOC, theory of computation, about step functions. Like you have state machines, not step functions, my bad. So in the state machine, you define states. If this works, then go to this state, this, and then go to end. So just like that, we have step functions in our like this service, and you create state machines in that. So what are the use case of it? So let's go back to Instagram example. Whenever you upload your photo or video on Instagram, it could be of 10 MB or 5 MB or XYZ. And whenever this, so let's say they are using AWS. So whenever you upload something on Instagram, they store it on S3. Now, on S3, this size of the image is 5 MB or 10 MB. But if you go to explore section of Instagram, it will like load hundreds or 50 of images at like seconds. So if they have like 10 MB of images in the explore section, then it will take like 3 minutes to load them. So what they do is create a thumbnail of your image and then store that version in S3 again. So they will create a 1 MB and 50 KB, 500 KB version of your image. Now, if you go to explore section, then you will have like grid of 10 images or 12 images. Now those images are of size 500 KB because they are small size and the load time is faster. Now, if you open it, it will be of original size or 2 MB size near to original, which is a compressed image, and again it will load faster. So you don't see the original image, you'll see like compressed image of yours on the application. So how to create those different types of images? So you can use step function. So whenever something is uploaded on S3, trigger the Lambda function, create 3 versions of your image from the Lambda function, store it in some another bucket, and do the XYZ thing. So you can orchestrate those things in a state machine here, like create states of it. So you can always use just Lambda function in S3 because of the trigger application, but this is also a use case. Also, like you might have heard of like Amazon moved to monolithic instead of microservice architecture recently, and like so it doesn't mean like microservice is worst or monolith is not good, but it was the use case. The issue was like in their Amazon Prime, whenever the media house uploads the movie on Prime, it calls a step function. The step function encodes the video and store different version like HD, 4K, SHD versions, and then do the processing on the video and store it somewhere. So they were using step functions, but using step function is a costly thing. Like for every state, it costs you some bucks. So instead of using step functions, they use the monolithic service, which does everything, and that way they were saving in calling different services, and then it saved like 90% of their revenue for that use case. But for other use case, monolith could be not good, and microservice will be better. So it always depends on the use case. Okay, so step functions. So let's go to start and create your own. So when you create a step function, the base step function is like this. There is one start and there is one end, and in between you can have multiple states. So just like states you have in your state machine, in step function you have these many options. First is choices, which is if else. So if choice is true or false, then so like if this start, and I'll also put, so first of all I'll put this Lambda action here. So if my Lambda is returning something, and that variable is true, then go to this. If it is false, then go to this. So this is called choice. Parallel is like you can have parallel processing here. So let's say if I put lambda here and one more lambda here. So if I come to this state, then it will execute these both things in parallel. Then map is like a for loop. So you will have a map and then you put a condition in the map. So it is just like a for loop. Pass is like it doesn't do anything. It just pass the state from this to this. Wait is like you have a delay, wait. Success is like when you put success at the end of things. So if we are at this pathway, then it is success, and if we are at this pathway, it is failed. So your state machine is failed. So these are like flow in your state machines. And in actions, what is action you can run on this state machines are like there are many actions provided by AWS. Like it is very tightly integrated with other services as well. So you'll have like many things from state machines. So for our application, let's just remove this thing. I'll create a base state machine. So first state is when I start this state machine, I want to call a lambda function. So first I'll create a lambda function. I'll select Python, lab role, create. Then I wrote a state machine program. I'll just copy this and paste it here. So basically what this program does is like in the event, it asks for user key, then it generates a user ID, and there is a array of true and false. So payment status, so like there is a random.choice here, so it will either pass true or false to this, and this lambda will return the things back to the state machine. So this thing is like it will either send true or false, and these things I'm generating. So I'll deploy it. Okay, so in the lambda invoke, you need to first select the function. So state machine function I'll select. So I've selected the lambda function. Now I'll put choices here. So I'm sending some data from the lambda function, this data. So I'm sending a status here, which could be true or false. So I need to check this status. So this lambda is sending me some data, and I've selected choices, which is like an if and else. So inside the choices, you can have multiple rules. So if I select any rule number 1, and then add a condition, then first is like not or is. So when you put exclamation, it is not. So now you are sending some data from lambda function. So I need to access this payment status value from this JSON. So how do I access it? So to do that, what you do is $, dot, and then this. So whatever variable you want to access from the JSON, you use $, and then $, and then name of the key. Now comparing operator should be equal to Boolean constant and true. So if my status is true, then go to the state. So I'll put DynamoDB put item here. So I want to, whenever the status is true, I want to store that data in DynamoDB is what I want to do. And if status is, so first of all, I'll write the logic here. So table name, DynamoDB table name is users item. So in this, I'll first write. So there is one thing in DynamoDB which is different than everything else, which is like when you want to pass any key to DynamoDB, you'll have to write user_id dot $, like opposite of what you do here. And here I'll write user_id. So this thing is coming from this state, which is coming from this state, which is coming from here. So user ID I'm sending. So I'm accessing this user ID from here. Username $.username. So I'll just store those two things. So let's say if it is username. Okay, so I'm storing this item in this table. And now again going back to the choice, and in the I'll create a new rule number 2, add conditions. So $.status equal to Boolean constant false. So if status is true, save it to DynamoDB. If status is false, then do something. So what I want to do is SNS publish. So I want to send a notification to SNS if the status is false. And for choices, there's always a default rule also. So I'll also put it to this SNS publish. So this thing I have like created so far. So for SNS, I'll have to go to SNS. I'll explain SNS later. Like what is it? I'll just first create it. So create a topic. Topic name is step function SNS. Create a topic. Create a subscriber. Email suresh.r@ca. Continue. When I write create a topic and subscriber, I'll get an email. This is all SNS parts, so I'll just do it and then explain it later. I'll confirm the subscription. Now if I go back to state machine, go to this and select the state machine. So I'll select the one which I've just created, step function SNS. So I have configured database and SNS. Now I'll put this success and fail here. So far I have created a state machine like this. Input will go to Lambda, then choices. Then if it is true, then it will go to DynamoDB and it will be success. If it is false, it will go to SNS and it will fail. One more thing which is left is assign the role to step function. So I'll assign lab role here and then click on create. So it will create a state machine for me. So this state machine is active. So if I go to start execution, then it asks for some JSON input. So I'll go to this Lambda. It asks for user and user ID. So I'll put this data here and click on start execution. So it will call the Lambda function. Dynamo Python error. So did I create user table? Okay, so there is no users table. So I'll create a user table here. Okay, so I'll execute the state machine again. Also you can see fail status here. So start execution, paste this and start. So when I ran the Lambda function, it could either give true or false. So it gave true to me. So inside the choices, it was true. So it called this put item API and it was success. So if I go to DynamoDB, users table, explore table, and then run it, so I can see Team Cook here. But if I run this again, new execution, I'll remove this because I'm creating it dynamically, and I'll write Elon Musk, copy and paste. Now let's see if it is failing, and it failed. So it returned a false statement and it called this SNS publish and it then moved to fail. So if I go to my email, then I'm receiving this input. So like Elon Musk username I sent, the status was failed, and this was user ID which was created by on the fly. So basically the flow was like running this Lambda function, providing if the payment is successful or not. If the payment was successful, store the details in DynamoDB. If payment is failed, send an email notification to me. So I orchestrated this thing using step function. So you can do multiple steps using and create a flow using step functions. So this is basically the use case of step functions. Any question in this? Okay, now moving to SNS part, which I skipped. So SNS provides a pub/sub mechanism. So what pub/sub is, like in SNS, you create topics. So let's say, let's take an example of newsletters. So you follow newsletter, right? You provide your email and then you subscribe to a newsletter. And then whenever the creator posts a blog, you will get an email and you'll have a blog in your email. So this is what newsletter is. So let's say there is a content creator like me. I have my blog and you have subscribed to my blog, right? So for creating a blog, I'll create a topic like Purvesh blog as a topic, and I'm the publisher of that topic. And to this topic, multiple people or multiple entities can subscribe to that topic. So you have subscribed to my topic. Now, whenever I push something, all my subscribers of that topic will be notified. And this is what SNS does. And it could be an email, an HTTP request, anything. It could be anything. So if I go to SNS, go to topics, create subscription. So in the protocol, it could be SMS, HTTPS, HTTP, email, JSON, email, Lambda calling, SQS, and all. So I selected this email. So that's why you ask for email address. So I have subscribed. So like this user, this email address has subscribed to the topic which I've created, this topic. So whenever I push anything to this topic, all the subscribers will be notified. So this is what pub/sub mechanism does. It is publish subscribe model. So any question in step functions? And you can also visualize this here. So like it's good for debugging here, and for all the logs are also shown here. So you can go to anyone and then you can see like what is the input and output. This was the input to this state, and then this was that. So you can debug your step function like this as well. And the only thing to remember is like to access this key, $.user is the thing which you need to remember. So any question here? Any question in Lambda, API Gateway, SNS, step functions? Okay, so I think this was all for today's lab. Thank you.